So in this next example that we are going to do, we are going to employ some strategy that we must apply when we are only having an even powers of sine x, right? Even powers of sine x and then cos x. When we are having only an even powers of sine x and cos x. For integrals of this type, we must be able to know some identities of head. And those identities came from the trigonometric identities, and then this is something that you must know wherever you find yourself. And then before we proceed, I would like us to go through some of the trig identities, or let me say the compound, especially the compound angles, so that wherever you are going to meet such formulas or such thing, you are not going to find yourself wanting. So let's look at something here. We for the compound angles, we have our sine of a plus b, which is equal to sine a cos b plus cos a sine b. We also have the minus 1, which is a minus b, but we are not interested in it for now. Or if there's a need, we will look at it. Or let me write it so that at least you get some bit of idea. Sine a minus b is equal to sine a cos b minus cos a sine b. Let's look at cos as well. We also have cos a plus b, which is equal to cos a cos b minus sine a sine b. Looking at the negative aspect, we are going to have cos of a minus b, which is equal to cos a cos b minus, or plus, plus sine a sine b. So this is the four main, the four most important trig identities that I want us to take a look at, because most of the trig identities comes from these four identities, or four compound angles. Right? This is what we are going to look at. And then let's look at something here. The two trig identities that I want you to know, for the ones in which we are going to have all even powers of sine x and cos x, will be sine square x is equal to 1 over 2 minus 1 over 2 cos 2x. You know, if you are being given a question like this, and then you have been able to express it in this form, it becomes far easier for you to be able to solve this without wasting much time. But when it is in the form of this for you to integrate, and if you don't take care, you find yourself wanting. That's why these trig identities are very important. They are fundamental in solving some integrals involving trig functions. The other identity that I want you to know is also the cos square of x, which is equal to 1 over 2 plus 1 over 2 cos 2x. And at the end of the day, we are going to get 1 plus cos 2x all over 2. Let's look at something here. You can see 2x here, 2x here, you can see 2x here. What does that tell you? this tells us that the A and the B that I wrote over here, they are of identical. So it was rewritten as cos of x plus x. So in this case, we can write it as cos of A plus A or cos of B plus B, which is going to give us either cos 2A or cos 2B, depending on the variable that you want to use. That's how this came about. So, and we are generating it from a compound angle. So looking at this, when we say cos x plus x, which is equivalent to cos A plus A. So for now, let's use cos x plus x, and in that case, we are going to have cos 2x. I said we are using cos x plus x. They are all the same, but I want you to use x so that you'll be conversant with it. Cos 2x. And when you look at cos 2x, now we are going to replace this b by and the a by x and x. And at the end of the day, when you look at this place, we are going to have cos x minus sin x, which is cos 2x equal to cos x minus sin x. So at the end of the day, we are going to have cos 2x to be equal to cos square of x minus sin square of x. Right? And as I told you earlier on, we have a very well-known trigonometric identity, which is what? Sin square x plus cos square x is equal to 1. So in this case, if I want to get everything in terms of maybe sine at the right hand side, I can say that sine, maybe, okay, let's get everything in terms of cos. For the meantime, we will come to the sine. So sine square of x is equal to 1 minus cos square of x. And in this case, you will be able to substitute this one inside this place, or let me say this because it's the sine, it's sine square x. So we are substituting it inside this one. And at the end of the day, we are going to get cos of 2x equal to cos square of x minus, into brackets, remember it applies to everything over here. So we are going to get minus 1 minus cos square of x. So now that I have this, we can expand it to get something like cos 2x equal to cos square of x minus 1 plus cos square of x. And cos square of x plus cos square of x, we are going to get 2 cos square of x. So we are going to get cos 2x equal to 2 cos square of x minus 1. So in this case, if we want to make cos square x the subject, we can send this one to the other side. So we are going to get 2 cos square of x, which is equal to 1 plus cos 2x. And at the end of the day, we need to divide both sides by 2. So we are going to get our final answer to be cos square of x, which is equal to 1 over 2 plus cos 2x over 2. This is the same as what I wrote over here. Right? This is the same as what I wrote over here. And then this is how it came about. So understanding this thing, when you are given cos square of x, you'll be able to express it in terms of this. When you are given maybe, let's say cos power 5 of x, you'll be able to write it in the form cos power 4 of x cos x, because they are the same. Of which this one can also be written as cos square of x all power out 2 and then multiply by cos x. So in that case, you will be able to substitute this cos square of x in terms of this, and then you put it here. And then if there's any sign attached to it, you can make your u equal to the sign when you integrate or you differentiate to help you cancel out this cos over here. And then you will be left with only one common function, of which will be in terms of u for you to integrate in a simpler manner. The same thing applies to the sine square of x, which is 1 over 2 minus 1 over 2 cos 2x. As you can see, there's only a sign change which distinguishes between the cos square of x and then the sine square of x. The sign change is the sign in the sine case is negative, and then the cos case is positive. So when we did for the cos over here, we got positive. So when you are doing for the sine, when you get to this place, instead of making sine square x the subject here, make cos square x the subject. And at the end of the day, you are going to get 1 minus sine square x. So when you replace it to the cos here, you are going to get 1 minus sine square x minus sine square x. So at the end of the day, you are going to get 1 minus 2 sine square x, right? And then when you make sine square x the subject, you are going to get negative in between here. So please try and understand this trigonometric identity and how it came about, and trust me, it's going to be very useful for you whenever you encounter trigonometric integrals. So this identity is sometimes known as power reducing identities. As I said earlier on, when you are given a power of 5, power of 6, you'll be able to reduce it using this trig identity, and they may be derived from the double angle identities, which is what? Cos 2x, as I have already done that for you, which is cos square x minus sine square x, and then the Pythagoras theorem identity, which is cos square x plus sine square x, which is equal to 1. So please try and take time and then pause the video, rework on whatever I've derived here, and make sure that you're on the right context, and then do same for the sine. Make sure that you get the sine one to be sine square x equal to 1 over 2 minus 1 over 2 cos 2x, which is the same as 1 minus cos 2x all over 2. When you are able to do that, then we proceed to solve more questions, and then you apply such knowledge to solve them. I think everything will be fine. So please try and give a comment under the video, and then whatever lingo or whatever clarification that you need, or if you need further explanation on certain things, you can just give out